So there are variable energy and waveguides. Now, the waveguide that we have discussed, that is the main part of the linac. This thing. This is the main waveguide where the electrons are being accelerated. So this is the medical linacs or variable energy for different treatment. Obviously, in medical linac, we have separate different energies like 6 MV, 10 MV, 15 MV. So all these energies require different length of waveguides. So they are engineered based on the requirements. Right. So there are various traveling waveguides. So traveling waveguides means the RF wave travels inside the waveguide. And then the surfing example that I have given, like a man surfs on a sea wave, and that wave always accelerates the man because the man is always falling down. But as soon as the man falls down, the wave catches up, and the wave kind of takes the man high up in again, and then the man falls again. The same way, like man is always falling into the gravity and he is gaining energy, but the wave catches up and always lifts him up. The same way, when RF wave follows an electron from behind, those electrons fall in that electric field, but because of the constant RF wave from behind, the electrons again goes to a higher energy state and then accelerates. So those small acceleration adds up together, and then the electrons are accelerated using traveling waveguide. That is a example of traveling waveguide. In physics, there is another example called standing waves. So if you have like a reflector at the end and you throw a wave through it, you will get a reflection of the wave, and both these waves will interact, and you will have an interference, and because of that interference, you will have nodes. You will have nodes and antinodes, and that is called a standing wave. I hope like all you physicists must have an idea of standing waves. So those standing waves are also like bunched in different cavities, and those cavities, the way we have seen in klystron, same way those cavities are now used to accelerate those electrons in this case, and that is how this standing waveguide. Most of the variant machine uses standing waveguides, and most of the Electra machines use traveling waveguide. This is an example of standing waveguide. If you see, like this is how it looks like from inside. This is a not cross sectional. This is a sagittal view in like if you compare it with the medical image. So this is a sagittal image of this waveguide from inside. You have got different cavities inside. This is how it looks like. So each unit cell. So when you see like this red line represents like repulsion of electron, and this blue line represents acceleration of electrons. So when as soon as the electrons reaches at one point, they switch their polarity, and then they push the electrons again. So this is how this is achieved in standing waveguides. These are the nodes and antinodes. This is the point. The join where the red and blue joins is an antinode, and there is a node. So this is how the standing waveguide works. I hope this GIF explains it. In the traveling waveguide, you can see how it works. It's different from the standing waveguide, but it's usually longer than the standing waveguide because of the physics it requires. So you have got electron guns, you have got input coupler and then output coupler and those things. And then you have got, this is how the traveling waveguide works.